Welcome back to AP Statistics with Mr. Walton. Today we're going to talk more about Chapter 10 from the Practice of Statistics, 4th edition. In this case, we're going to talk about Section 2. So we're going to talk about the fact that we have two samples and we're talking about the means of those two samples. And can we use them in a test or can we use them for confidence intervals? So, first thing we want to look at is a little summation of all the different things we can do for our t-test or our t-interval using two samples with means. So if we're talking about significance test, please realize that we have options here of how we're going to set up our hypotheses, H sub O, H sub A. Almost always we say that there's no difference in the means, and then we look in H sub A that there is a difference in the means, and then we look at calculating our t-test statistic using this beautiful, lovely formula that I'm indicating right now. And don't forget, we have to either use technology or we have to use the minimum for degrees of freedom between n sub 1 minus 1 or n sub 2 minus 1. Also, let's make sure that we fix that we're talking about we really need to have an approximately normal distribution, and that we're going to talk about both of our samples being approximately normal, not just one. So either we have central limit theorem that works for both, or we're going to look at our Fry rules. Do we have large, medium, or small? If we have medium or small, we're going to graph the data. When we graph the data, that's of our sample, if our data appears approximately symmetric, then and only then can we say our sampling distribution, that's singular again, ladies and gentlemen, our sampling distribution is approximately normal. Again, we're going to relate to where we're looking if we're going to use our calculator to help us out. I'll highlight that for us. Otherwise, we can do both of these by hand. However, let's be reminded, we're going to use the TCDF function here. We're going to have a lower bound, upper bound. We're going to use degrees of freedom. And remember that our boundaries, our lower bound and our, have to be t values. This is in terms of t. So we need our test statistic as either the lower bound, or the upper bound. And again, if we go back and look up here, we have the confidence interval as, that's supposed to be x bar minus x bar with our t critical and our SE. Now remember, for t critical, we're talking about inverse t, which is 1 plus the confidence level divided by 2, comma, degrees of freedom. Remember, that's area to the left, comma, degrees of freedom. If you have inverse t, or you are going to use your green formula sheet, and you're going to use the more conservative measure for your t value. All right, let's look at our number one example right here, right now. Everybody's going to read this carefully. I'll give you just a moment. Okay, so try to set up your two parameters by defining them, and then try to set up your hypotheses. Mine will pop up in just a moment. All right. And here I have mu sub w and mu sub n, and I've talked about the fact that I have them equal to each other or not equal to each other, and that is solely based on the fact that they're asking about, is it different? All right, so that should help us with a heads up. Now we're talking about some summary statistics, and we have x bar sub w is equal to 113. We have our s sub w is equal to 12, and we have n sub w is equal to 54. Over here, we're looking at x bar sub n is equal to 123, that our s sub n is equal to 15, and our n2 is equal to 55. Right, for our overall summary statistics, okay, now we're talking about our test statistic is our n sub n, and that we have this is equal to, and then we have degrees of freedom, and I used my technology to get 102.83. All right. Once we have our summary statistics, we have our conditions. Try to get those done, and mine will pop up just in a moment. All right, so we have our conditions being met, and now we can say, since all conditions are met, I will calculate a two-sample t-test, and now I'm looking at what's the probability that t is less than negative 3.847, or the probability that t is greater than 3.847. Combined, so I'm going to have this beautiful two-tailed look. All right, and then I'm going to calculate my probability value, which is in this case 0.00021. Wow. Okay, then what do we say for our money statement? Money statement, yes. Since my p-value is lower than any typical alpha level, we will reject H sub O. The evidence suggests there is a difference in mental skill scores. All right. Hopefully that makes sense. Now, let's look at the reasonability of this in terms of what they're asking in Part B. Suppose that a study using this design found a statistically significant result. Okay. Would it be reasonable to conclude that using a walker causes a change in the mean mental skill score? And explain our answer. And I'm hoping that before conclusively saying this, we can eliminate any lurking or confounding variables. Why are babies put in walkers? Does there have something to do with a difference in the babies as to why they're in a walker? So this is, in what we're looking for is reasonably explain why you're making your choice. And if it's a reasonable assumption, we're going to give you full credit. If not, then we're going to have to look at, I don't know that we can say this. But it needs to be a reasonable, critically thought out process that you're explaining. All right? This is 10.2. The other thing we could do is confidence intervals, and you'll see some of those in class. And good luck. It's AP Statistics.